Hello, everyone, and thank you for attending my presentation today. I'm glad to share with you the work that I've done during my PhD, together with my supervisor, James Eagan, from Université d'Elegant Paris, Institut Polytechnique de Paris. The work is on a cross-device affinity diagramming tool called ADQDA to demonstrate our vision for fluid and holistic qualitative data analysis experience. So in this paper, we are interested in a specific sense-making method called affinity diagramming. It is a spatial clustering technique where analysts manually move data items around and group them into clusters based on their similarity or relevance to a shared topic. Many of us might be more familiar when it is applied to scenarios such as brainstorming. Well, affinity diagramming is also largely applied to analyze qualitative materials, such as those collected from interviews, observations, and surveys. Affinity diagramming is basically a method using space to think, and many different activities are often involved in such sense-making processes. For example, here, what we see are the screenshots that I took from a documentary demonstrating the analysis process of a researcher who is trying to make sense of her interview data. And during the process, she may examine original materials, transfer the data into diagrams, and develops and compare multiple diagrams in the same time. We can see with paper, she's able to appropriate the available spaces to conduct these different activities and also to expand her thinking space, such as she spread out the multiple diagrams on the walls and even the documents to the ground. So both James and I have similar experience in using affinity diagram to analyze qualitative data. Yet we were always struggling to handle the analysis with current tools, no matter with paper or digital tools. While paper, though it's easy to be spread out, well, it is cumbersome and cognitive demanding to manage the large amounts of data, and it is also difficult for people to collaborate remotely. And digital tools, on the other hand, provide the ability to facilitate data management and also different kinds of collaboration, whereas current digital tools are not easy to be combined to expand the analysis space or to support multiple different activities. To better understand this sense-making process and discover common pain points, we further conducted informal interviews with 3 practitioners, 2 HCL researchers and 1 sociologist. And during the interviews, our participants shared their affinity diagrams with us and worked through how they generated them and the pain points that they face. Based on these interviews, together with literature review and reflections on our own experience, we identified a design space for digital tools to support qualitative data analysis. This design space contains 5 dimensions, namely the different analysis phases, the conceptual methods that analysts might adopt, the multiple analytic perspectives or lenses, as well as the digital devices engaged and the different collaboration styles. So to deep into more details, in the first dimension, we characterize the overall process into different analysis phases, basically to demonstrate how people go from this messy and structured data to a more structured sense. They often start from raw materials and they need to extract relevant information from data items, assign these data items into categories, clusters, and they also often need to form higher level concepts based on these categories. And the analysis may start from any phase based on the strategies take. For example, some analysts may perform open coding, that is start from the left part and moving right, while as others may perform close coding, start from the right and moving left, and frequently those two are actually mixed. We also find that no matter the strategies applied, users may iteratively flow between these different phases. For example, they may update the categories or concepts as more data items get extracted. So the key message of this dimension lies in these lines, these transitions. It illustrates the iterative and explorative nature of sense-making, and it also highly resembles the well-known sense-making model proposed by Perelli and Cart. Thus, when designing such digital tools, it is important to consider these transitions, and instead of treating them as isolated phases. So the second dimension is that within these analytic phases, we further find affinity diagramming is often conducted or coupled with another method called coding. As we see in the pictures, coding is a more structured form of analysis where analysts highlight relevant information directly in the document while reading, and they directly annotate them in the margin of the documents with keywords labels, often called codes. So in coding, ideas can be more quickly recorded, and since the analysis artifacts are embedded in the documents, thus it maintains its original context. While as during diagramming, it actually frees the analyst from the linear structure of the document so that they can explore the space to test the different ideas. And also the space can convey extra cognitive messages. So that we think coding and diagramming are complementary analysis methods, and they both together contribute to the cognitive interpretation of the data. And so in our design space, we draw these two methods, coding and diagramming, as the blue and orange components. And we put the lines between them to emphasize that though they are different methods, but they actually should be treated as conceptually identical since they both serve for a consistent analysis mental model. And the third dimension is what we call analytic lenses. Is basically we find that analysts often need to view data from different perspectives, thus generating multiple diagrams or multiple codes for a given data set. We thus represent these multiple perspectives as stacks of codes or stacks of diagrams in the design space. Moreover, we find that in an analysis, analysts may adopt different collaboration strategies as their analytic goals and their analysis context evolve. For example, we may have some analysts engage in same analysis phase, while others in a different phase. And they may use same or different conceptual methods, and they can work in the same location or from distributed work sites. Furthermore, the last dimension considers the interplay of different kinds of digital devices within the web of users' analysis activities. Well, analysts may have access to different sets of devices, and these different devices might align well with some specific tasks due to their physical affordances and computational properties. For example, when an analyst works from home, he may prefer to do coding with a laptop, whereas later when working in a lab, he might continue the analysis with affinity diagramming method on a large touch display. So these 5 dimensions altogether constitute the design space for qualitative data analysis. And the design space shows how these different analysis phases, the alternative methods, these multiple diagrams, and these devices can fit together in the overall sense-making process, and how they intertwine and interplay with each other. This design space also helps us to better understand current tools. If we use this design space as a lens, we find that many current tools only support on some specific parts of the space. For example, most tools only support one analysis method, either coding or diagramming. And they often impose a specific analysis ordering or analysis sequence. And current tools also tend to support specific collaboration styles or constraint on some certain type of devices. As a result, current tools tend to partition the overall analysis process into segmented pieces, and it is difficult for users to choose the methods they want or combine the spaces for the contextual needs. So we envision qualitative sense-making as a more fluid and holistic process where we imagine users can arbitrarily transition between these multiple analysis phases and switch between coding and diagramming as they see fit to their situated needs. They may work alone or adopt different collaboration styles, and they can appropriate any available digital devices for their tasks at hand, or to actually combine them when they need more space to think. So in order to demonstrate our vision, we built a proof of concept prototype, ADQDA. It is a collaborative cross-device system built on top of web streets using distributed web technologies. And let me briefly demonstrate how it works. Here we see, what we see is a user opens a coding view in her laptop and a diagramming view on a larger vertical display. As she's reading the document, she highlights the relevant text, and as we can see in the meantime, the highlights automatically turns to text snippets in the left region of the diagram. And in the coding view, she can further track these snippets and the context and code them by tagging these text snippets with code. And then she can transition from coding to diagramming, where she can directly drag the already coded snippets around and cluster them in space. Moreover, multiple collaborators can work on a same diagram by using a large wall-size display, while remote users can also join the analysis in real time. And they can also work on multiple diagrams, for example, to examine different perspectives of the data. And they can further generate hierarchical diagrams to explore higher level concepts. And during the process, users can request the context of a snippet across different hierarchical diagrams or check a participant's code in its original document by using an extra device like phone. So in order to facilitate these transitions, ADQDA employ different kinds of linking mechanisms. It automatically links associated artifacts across the different views that we saw, and it also synchronizes the updates as the analysis going on. ADQDA also maintains a bijunction linking between the coding artifacts and their equivalent diagramming artifacts. So these are the notes and highlights and tags and the same notes as we say in the videos, in order to facilitate a seamless transition between those two different conceptual methods. So through these links, no matter what the view the user is using, they can always have the most up-to-date and coherent analysis artifacts. To summarize, in this paper, we contribute a design space for affinity diagramming tools for qualitative data analysis, especially using an affinity diagramming technique, and a vision for a fluid and holistic qualitative data analysis experience. Together with the proof of concept prototype ADQDA as a web-based system, and also a series of demonstrative scenarios, which you can refer to more information in the paper. And thank you for your time. And I would like to take the chance to say that I just finished my PhD and now I'm available on the job market. So please feel free to contact me if you know any suitable opening positions. And thank you again for your attention, and I'm ready to take questions.
Thank you. That was a wonderful presentation. I would love to try out the tool at some point. So thank you for that. Do we have any questions in the audience or in the chat? And just a quick info for everyone, because of the technical hiccup, we will extend the session for a couple of minutes to also ask some questions about this talk. Then I will start with the first question. So I was wondering, since qualitative data analysis is inherently messy, and you said so in your talk, what were the challenges that you faced when designing the system?
Yeah, so for example, one of the challenges we face is like what we say, we can figure out analysts often transition from coding and diagramming, like really arbitrarily throughout the entire process. So we were thinking how we can save the user the efforts to synchronize the different sets of artifacts, and so basically make them can focus on their analysis instead of managing these messy artifacts and through different activities. Well, one challenge that we face is although we treat coding and diagramming as conceptually equivalent, but actually they are not identical, since, for example, coding text in the coding view does not provide necessary spatial information to determine the codes or the node's position in a diagram. So we think about different solutions, such as apply some algorithms to automatically position the nodes. But then in our interviews and also through our experience, we think that the spatial arrangement also plays a very important part in the analysis, like in the user's mental model. Thus, we ask the questions such as what I show here, where to put a highlight, a new note, and how to put a coded snippet within a cluster. And we implement different kinds of solutions. For example, like a messy pile, as we can see here. Then it's, as we see in the video, it's sort of maintain this messiness, but map the highlights in a space. And then also we do this inbox and outbox mechanism. I have a short video. So when the user is coding the coding diagram, and later on, actually when she transitioned to do diagramming, and the previously coded texts are actually put in this encode box of this same note. So it also helps users to maintain the awareness as different things going on through the multiple views, maybe at different period of time.
That's great. Thank you so much. And I find it an interesting parallel to Jason's work, the inherent meaning of space or locating something on the canvas. So thank you so much for that. Okay, then let's give a round of applause for all our speakers.